welcome back to the class. How are you all? How's the chapter is going on? How's your studies going on regarding this chapter? Are you able to do this chapter? Are you able to solve the question of this chapter? I hope everything is going well. So, my dear students, like in the last session, till the last session, what we have done is we have discussed about the properties of liquid, solid, liquid, and gases, and even though we have seen about the evaporation and the melting point, boiling point, we have covered up all of these things exactly. Now, students, today we are going to start these topics, that is the evaporation and the factors affecting of the evaporation, and what's the difference between the boiling point and the evaporation. Even the student, in the last session, I have told you that what's the exact difference between the boiling point and evaporation. So we'll see that. Okay. Then we are going to start with the gas laws. See, student, gas is all, you can see that the atmosphere, the air which we are having around us, it is completely having the mixture of gases. Even though there are dust particles, water particles are also there, but if we see, the most amount of the air contains gaseous mixture, exactly, nitrogen, oxygen, and different type of gases. It's not like that only nitrogen and oxygen is there. We are having different type of gases, students. Okay. So that's how I can say that we are going to study about the sum of the gas law, and why I'm teaching you these gas laws, whereas these are not in your syllabus for your point of view of your school examination or boards examination. It's just that it's an advanced part of it, that when you are going to a class 11th, you are getting all of these. Okay, so what I want you, that when you are going to a class 11th, you will not feel like that, oh my god, what we are going to start today or what we are reading right now, because student, it happens with everyone. Like, seriously, if I tell you my story, so when I jump, like when I go from like when I promoted, okay, it happened with me that I just jumble up sometimes. Just give me a second. Yes. So yes, what happened is that when I've gone from, like when I have passed my 10th class, so what happened when I was 11th? So what I have seen, the perspective of your studies, the perspective of your subject is going to be completely changed. What I have find out, because till 10th we are studying okay, this is chemistry, this is physics, but when you go to your class 11th and 12th, and when you are preparing for JEE or NEET, so it will be a very, like, you will find out, so there is a difference, like if your 10th standard is at this level, so the 11th will be at this level. So that's the difference, and that is why, student, I don't want to feel you like this, that I'm going to teach these laws today to you. And these are very simple, they are nothing like that they are very difficult one, or very what I can say, very typical or something like that, or somewhat like they are terrible. They all are easy. Fine. So, students, starting with the evaporation, first of all, that what's the evaporation is. So, my dear students, if I'm not wrong, evaporation is a process like which we have studied yesterday also, that when we take water and when we heat or boil it, so that water converts into the vapors, and then we call it as the evaporation. Exactly, because the vapors are converting. So we can say that the evaporation is a process in which liquid state changes to the gaseous state, or we can say that to the vapor form. So we called it as the evaporation process. Fine. Now we have to see that what are the factors affecting to it, that by which increasing which factor the evaporation is going to be increased, or by decreasing which factor the evaporation is going to be decreased. So we are going to discuss all of these factors right now, students. Fine. So we'll see that, but first of all, I want to show you some video here, because it is very interesting to watch videos. Okay, so let's start with this video. Okay, just give me a minute. I think this video is not working right now. But it's okay if it is not working, so we can continue with there because I'm your teacher. So you, I think so we don't need any video right now if I'm here to you, so I can explain you each and everything very clearly. So okay, starting with the evaporation. So student, as I told you that what's the evaporation is, that when liquid convert into the gaseous form or to the vapors form, we called it as the evaporation process. Exactly. So that means we can say that when we boil water, so it evaporates into the vapor form, and that's the evaporation process. Okay, and but we'll see that what's the difference in the boiling point and the evaporation. Now students, we see that what are the factors affecting evaporation. Okay, so we are going to discuss all of these factors right now. So it's just that student, as I told you, evaporation is a process in which a liquid state or the water converted into the gaseous state of matter that we called as the vapor. So it is the evaporation process. Fine. Now, what's the factors affecting the evaporation? So see student, first of all, starting with the temperature. Okay, so I'll explain you one by one that what are the, like how the factors are affecting. So first is the temperature. Second is the surface area. Okay, third is the humidity. Okay, and fourth is the wind speed. Okay, so these are the factors which affect the rate of the evaporation. Okay, now how they affect it, so we are going to discuss that only. See student, for evaporation what we require, that we have to heat the liquid state. Exactly, that means we require temperature. If student, if I say if the temperature is 100 degrees Celsius for water, fine, and if I'm increasing that temperature, so what will happen student? Yes, exactly, the boiling point will remain at 100 degrees Celsius, because yesterday we have learned one of the concept, the concept of latent heat of vaporization. That what happened, that at the boiling point is that point where both of the state, like the both state of matter present. But what will happen if we are continuously giving the heat to that liquid state, so what will happen, the temperature will remain at that particular boiling point, but that extra heat is going to be converted into the kinetic energy, and that's how all of the water is going to be converted into the vapor. So that's how student, if I'm increasing the temperature, so what we can see, that the evaporation is going to be increased. For example student, if you are taking pen, like take two pens and take water, equal amount of water in both of them. Okay, and heat them. And if I'll say that heat the first pen for 5 minutes and heat the second pen for the 10 minutes, so what will happen student, the pen which has been heated for the 5 minutes, you will see that it has been not that much heat as compared to the second one which has been heated for the 10 minutes. That means for the second one I have increased the temperature. If I have increased the temperature for the second one, so I have find it out that the most of the water has been converted into the vapor form. That means student, by increasing the temperature, the evaporation obviously going to be increased. So I can write down here this point: if the temperature increases, so the evaporation is also going to be increased. Fine. Exactly student, you have also seen all of these things, that whenever we want to boil our water, we just give a continuous heat to that water, so that most of the water, even though, okay, so yeah, I got one example in my mind. Whenever I used to prepare noodles, Maggie, so what happens student, that it happened with me that I put lots of water in it, and in my family it's like that, they don't like soupy type of Maggie, they just want a very dry Maggie. So what I have to do is that I have to heat it for a longer time, so that all of the water is going to be converted into the vapor form. Exactly, so that all of the water can evaporate. So that's how what I'm doing is that I'm increasing the temperature. That means continuously I'm providing the heat to that particular Maggie, and what happens student, that the extra amount of the water which is present there, it is converting into the vapor form. The temperature is not increasing, temperature will remain at particular boiling point, but the extra amount of heat which I am giving, it is converting into the form of the kinetic energy, and the particles are moving at the faster rate and moving to away from each other, and that's how the shape is distorted, as we have discussed yesterday. That is the latent heat of vaporization and the latent heat of fusion. So that's the point, and that's how when all of the water has been evaporate from the Maggie, and we get the dry Maggie. Exactly students, so that's the point, that when we increase the temperature, so the evaporation increases. Fine. Okay, now surface area. That what's the surface area role is? See, students, surface area means that the particular utensil or particular plate, or I can say that any saucer or cup we are taking. So that what happens? So that the evaporation. What's the effect of the evaporation? See, student, when we are having the more surface area, evaporation will take more easily. Why? See, how I can say, mm, because I want to take one such example that you can just what happened. Okay, okay, yeah. What I can do, that we are having one cup and we are having one saucer. Okay, you are taking coffee in one cup, and what you will do that in that cup, if you are taking that, the coffee is not going to be that cooler to cool. Easily, but when I take that coffee into the saucer, so what I find out that the coffee is going to be cool more faster. So it is because, student, that the particles find out the more surface area. Okay, and if they find out the more surface area, so what will happen that the evaporation process takes place very easily. Okay, so that's the surface area phenomena, students. Fine. So I can say that when surface area, if I increase the area, so the evaporation also increases. For example, student, like whenever we, okay, again I'll take the example of Maggie. If the same amount of the Maggie I'm preparing in one big pan, and I'm preparing the same amount of Maggie in a small pan, so the evaporation of the water will take more time as compared to this. So that is why when we increase the surface area, so the evaporation also increases. Fine. Good. Now, humidity. You know what's the humidity? So, you students, humidity is when we are having moisture in the atmosphere. For example, we call it like a winter. Oh, sorry, not winter season, rainy season. So, when the rainy season is there, so we can feel that there is the moisture in the atmosphere, or we can say that there is some water particles in the air in the in more amount. So, due to which what happens, student, that the evaporation process decreases, because if the more water particles are present in the atmosphere, and in the case of the rainy season, there is no sun, exactly, the clouds are overall there. So what happened that the heat of the sun is not coming on the earth, so that the all of the water get evaporates, exactly. So what happened when the humidity is there, when there is no sun, that means moisture is around us. So what will happen, due to that, evaporation decreases. What my point? Because we can see that humidity, when we are having water particles, so what will happen that the first of all, the atmosphere try to evaporate that extra moisture which is present into the atmosphere, and that's how, if we are hanging the clothes, you can take this example. Like from this example, humidity and wind speed both are going to be clear in your mind. See, student, first condition we can take of the rainy season, and we have we have washed some 10-20 clothes, and there is no sun, and there is just rainy season and the moisture all around it. So you have noticed that in the case of the rainy seasons, clothes are not getting dry very easily, even though if you are drying in your washing machine also, but we need to dry the clothes in the presence of the sun as well. So what happened, what we will see, that we don't find out that the clothes are taking so much of time for the drying, but the same condition will be there when there is the sun, proper sun will be there, and we'll find out that the clothes are getting dry very easily. So what's that? Because they are getting proper heat, and when the humidity is there, moisture is there, and there is no sun, so what we find out that the evaporation is less. So you can see in the summer and winter also, that in the winter season that the clothes dry, it takes some time to dry the clothes, but in the summer season clothes dry very easily, whether they are the cotton clothes, and as well as there is the more heat, more temperature, that means in summer temperature increases, that's why evaporation also increases. So that is about the humidity, students, that when humidity increases, evaporation decreases. So this is one of the factor which affect the evaporation in the reverse form. That means it is not directly proportional to it. Fine, it is inversely proportional. Inversely proportional means humidity increases, evaporation decreases, and if the evaporation decreases, evaporation increases, so humidity decreases. So that's the inversely proportional. Okay, and directly proportional means if one factor is increasing, so the factor will also increase that much, and if the other factor decreases, so the another one will also decrease that much. So that's the directly proportional. Now wind speed, student. See, even though if the humidity is there but there is the wind, that the wind is blowing at a very fast speed, so you'll find out that your clothes are going to be dry very faster. So that is the point of view, student, that when the speed of the wind is high, so the evaporation process also increases. So you can say that the wind speed is directly proportional to the evaporation process. That means when you when there is the more wind speed, so the evaporation also increases. So that is the wind speed factor. So I can write down wind speed increases, so the evaporation also increases. So these are the factors, students, which affect the evaporation process. Okay, now I want to I want to ask you one question, that ever what I want to ask the question is that have you ever seen that the nail paint removers we are having, that whenever we apply that nail paint removers over our hand, so we feel cool at that particular portion. So why we feel like that? Or even though in the case of the summer seasons we want to wear the cotton clothes, we don't wear the woolen clothes, so why is that? So the students, the point of view behind it is, what happens, student, that the nail paint remover, when we apply over our hand or something like that, so the what happened, that the nail paint remover is volatile in nature. Volatile means that it will directly convert into the vapors. Okay, so what happened, so that into vapors at faster rate. Okay, so what happened, when I put the drop of the nail paint remover over my hand, so that nail paint remover will absorb the heat from my hand, and it will get evaporate into the atmosphere. Exactly, student, for the evaporation from liquid to gas we require some heat, so that it will convert from liquid to gas. Exactly. So that nail paint remover drop will absorb the heat from my hand, because you know na, our body's our body temperature is 37 degrees Celsius normally. So that is why it will absorb that heat from my hand and it will get evaporate. But now the heat has been absorbed from my hand, so at that particular point from where the nail paint remover drop has been evaporated, so at that particular point the heat has been decreased, the temperature has been decreased. So when the temperature has been decreased, so I will feel cool at that particular point. So that is why, student, evaporation process always result in the cooling. Same in the summer seasons, when we wear the cotton clothes, and in the summer season everyone gets sweat. Okay, sweating is there. So when sweat comes out of our body, so the cotton clothes absorb that sweat, and when they absorb that sweat, so that sweat will evaporate into the atmosphere by absorbing the heat from inside our body, because it is getting that heat from our body, so that it is converting into the vapor form. Exactly. So what will happen, student, when it is absorbing the heat from our body, so the temperature of body is going to be decreased, not that much, like 37 to 30 it is going to be like that. No, 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 not like that. It's just that very minute, like the very simple difference will be there, but exactly due to that we feel some coolness. Even those students, when if you have ever seen that, for example, in the summer season you have gone somewhere at 2:30 p.m. or 2 p.m. when the sun like is at the top of our head. That's a the so we feel very heat, the temperature is very high at that particular time, and you are completely sweating, and when you come to your house and you open up the fan or you open up the AC, so you feel very cool, your body feel very cool. So what's the process is, because the sweat which is coming out your body, it evaporates due to the wind speed of the fan. What fan do? Fan give the wind speed. So due to that wind speed, when you increase the wind speed, so the sweat which is present in your, like, which is coming out your body, so it get evaporate into the atmosphere because of that wind speed. Because when wind speed increases, you can see that the evaporation process also increases. But due to evaporate that liquid into the vapor form, what it will require, it will require heat, and that heat from where it is getting, from our body. So that is how our body feel cool at that particular time. So you can say that the evaporation process result into the cooling process. So that are the factors affecting, and this is the reason. Fine, I hope you all get this point. Okay, now, what's the difference in the boiling point and the evaporation? It's like, student, that generally people think that the evaporation and boiling point both are the same thing, but it's not like that, student. Both are, yes, I can say that both are the same thing, that liquid convert into the vapor, but it's like that there is some minute difference between these two. What? See, evaporation is a normal process that occurs when the liquid form changes into the gaseous form while causing an increase in the pressure or the temperature. Exactly, but the boiling is the unnatural process where the liquids get heated up and vaporized due to the continuous heating of the liquid. See, student, as I told you that if you remember from the last session, the evaporation is always below the boiling point. For example, for example, if there is the water, and if I am heating it to the 780 degrees 780 degrees celsius, 78 degrees celsius, 780, what I'm saying, 78 degrees celsius, so at that point there is the evaporation process. But when it is going to be heated to 100 degrees celsius, so at that point it starts boiling. That means, student, you can say that the evaporation done below the melting boiling point, but the boiling point is that the boiling starts when the particular liquid state reaches to that boiling point. Okay. And even the student, in the case of the evaporation, it is just a surface phenomena. That means the liquid which is present at the mm, surface, that liquid is going to be evaporate. But when the boiling started, so all of the liquid is going to be converted into the vapors. So that is why, students, when we heat up for the longer time, so what will happen, that the boiling process will take place, and that's how all of the water converts into the vapors. For example, when we prepare the salt from the sea water, you know this thing that the sea water is salty in nature and we prepare salt from it. So what we'll do, we'll dig the pit, and that's how we pour the water in that pit. And after some time, what we see, that all of the salt was there because all of the water has been evaporated. That's why you can say that the boiling will take place when we increase the heat for, like, we when we are increasing the heat for a continuous time. So that's how the boiling process takes place. And even though, if you have seen that when you have taken the water in one pan and you start heating it, so you will find out that okay, vapors are forming, but you didn't see that bubbles forming. But when it reaches to its boiling point, so now that the boiling start, and you can see the bubbles, and even though you can heard, like, you can hear that sound also, that is the good 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 good, because of that boiling. Okay. So that's the point, student. This is the difference in the boiling point and the evaporation, that the evaporation takes place when the like below the boiling point, and the boiling starts when the particular liquid state reaches to its boiling point. Fine. Okay, very nice. I hope you are getting everything. You are not getting bored of it? Actually, no, because it's a very interesting thing which I can say. You see, now when you are going to wear the cotton clothes in summer, so you'll say that yes, yes, the thing is that which we have seen in our class, that is the correct reason about it. Why? Because whenever you are going out and when you are coming to the house, coming back to your home, what you will do, you switch on the fan or switch on the AC and you'll feel cool, and then you realize, oh my god, that now the sweat has been evaporated from my body, and that's how my temperature has been decreased down and I'm feeling cool. Okay. So these are the evaporation process, students. Okay. Now gas laws. Now coming to the different part. Now this is the interesting part as well, because we are going to study about the gas laws. See, student, now the gas, you know what the gas is. Gas is the third states of the matter, and even though in the case of the gas, what we have seen, that the force of attraction between the particles are very less, particles are very far apart from each other, the distance between them is very high. Exactly. And due to which, student, they are compressible in nature, their kinetic energy is very high. So that's how, student, we are going to study the gas laws. Now what are the gas laws, student? So we have seen that there are some group of the laws which tell about the behavior of the gases, relation between the volume, temperature, pressure, and amount of the gaseous substance. So we are going to study all of these laws right now. So first law is here. Okay, so this is the explanation. We'll see that also. So first law is here, that is the Boyle's law. That means that there was scientist named as Boyle, and he has given us the Boyle's temperature, Boyle's law, not Boyle's temperature, Boyle's law. So according to him, what is the law is that he gives the relationship between the pressure and the volume. See, student, if in this picture you can see that what happened, that the okay, I'll tell you here what he give the relation to it. I'll show you. Just give me a minute. Okay. So first is Boyle's law. See student, he gave the relationship between the pressure and volume of the gas. That is, the pressure is P and volume is V. See student, if in one container you are having some gases present there, and if you apply the pressure over that gas, so what will happen, that the particles will come closer to each other, and after that what you have observed, that yes, now the volume has been changed. For example student, if I show you in this picture, just give me a minute. Yes. See, in this picture, what you can see, student, that initially this is the volume of the gas, that the gaseous particles are all around of this container. And when you apply the pressure over it, now the pressure is not that much high. You haven't applied any pressure. So what you have seen, that the pressure is less. You can see here that the pressure is less. So you can see that the volume is more. Exactly. But when you have applied the pressure, when you have applied the 5 kilogram of the pressure over there, so what will happen? The particles will come closer, and when the particles are coming closer, so you can see the volume is going to be decreased. So you can say when the pressure is more, so the volume is less. That means if I increase the pressure, the volume is going to be decreased, and if I decrease the pressure, the volume is going to be increased. So what's the factor is, we can say that from here student, that the pressure is inversely proportional to the volume. That means if you increase the pressure, so what will happen, the particles will come closer to each other, and that's how the volume is going to be decreased. And if you decrease the pressure, so what will happen, particles will try to move here and there of the gases, because you know the kinetic energy of the particles of gases are very high, so they will try to move here and there, and that's how student the volume is going to be increased. So that's the condition student. Now you can see for this first beaker, they have given it as the P1 is inversely proportional to V1, and for the second beaker it is the P2 is inversely proportional to V2. So what I can write down from here students, that I can write down it in the form of, that it is the P1 V1 is equals to K, that is the constant, and the P2 V2 is also equals to K, that is the constant, because I have to remove this inversely, that this is proportionality sign, so I have to use some constant. And now these two are same to each other, so what I can write down, that the P1 V1 is equals to P2 V2. So this is the equation of the Boyle's law. So what's the Boyle's law says, that when the pressure increases, volume decreases, that both are inversely proportional, and this is the equation for the Boyle's law, that the P1 V1 is equals to P2 V2. That means initial pressure and the initial volume, and then final pressure and the final volume. So that is the Boyle's law student. Okay. Now coming to the next law, that is the Charles law. Now what's the Charles law says student? Charles law says that, yes, one more important thing student here, what I forgot to tell you, that in the case of the Boyle's law, when the pressure and volume we are seeing, so at this condition the temperature is constant, temperature is not changing. Okay, so just remember this thing, temperature is constant, only pressure and volume is variable. It is very important to remember this point. Now the Charles law. What's the Charles law says that? Charles law states that at a constant pressure, that means when the pressure is constant, the volume of gas is directly proportional to the temperature in a closed system. In a closed system, yeah, remember this thing, when both of, see, initially when the temperature is less, when we haven't increased the temperature, so the volume is less, and when we have increased the temperature, so the volume is more. How we can say that student? See, when for example student, if I take the example of water, so what I can see, that I have taken the pen and I'm having some water in it. Now what happened, I'm heating it. So initially the temperature is low, so the volume of the water is less. That the volume, you can see that when the temperature is less, so it is the volume of the water. But when I increase the heat process, so that water is converting into the vapors, and you know this thing, that the vapors will occupy the more volume as compared to the liquid. So what we can see student, that when the when the temperature increases, so volume also increases. So what I can write down here, that it is the It is a very important thing, first of all, that at constant pressure, the pressure must be constant. The temperature is directly proportional to volume. That means when temperature increases, volume also increases. You can also imagine, student, when I'm increasing the temperature, so what will happen? The particles of the gas will acquire more kinetic energy, and they will try to move here and there with more fast speed. And when they will try to move here and there, so what will happen? They will result in the increase in the volume. And if I decrease the temperature, so the kinetic energy also decreases, and what will happen? They will not try to move here and there that much. So in that condition, the volume decreases. Okay, so if I say for the first condition, initial condition, when I haven't increased the temperature, so I'm taking it as the T1. So this T1 is directly proportional to V1. Second condition, when I have increased the temperature, so it is just that it is T2, that the temperature is T2 at that point, and it is the V2, the volume has been changed. So what I can see that from here, that it is V1 by T1 is equals to constant, because I'm removing this sign. V2 by T2 is equals to K, and both are equal to each other. So what I can write down, V1 by T1 is equals to V2 by T2. So this is the Charles law, students. Fine. I hope you got this point. Okay, so these are the two laws which we have discussed right now. Now coming to the third law. I hope you are getting now, like how it is functioning. See, all the things are depending upon the particles movement. If the particles are moving with the high speed and occupying more space, so the volume is going to be increased. And how it is going to be increased? When the temperature is increased. Okay, and if the temperature is decreased, so the particles will remain into their particular position. The kinetic energy will be less, and the volume will be less. For example, student, if I compare the volume of one solid material and one gaseous material, you can see that the gas in the atmosphere are occupying all of the atmosphere. But if I keep one solid box, that the iron box, in the atmosphere, or if I put this pen in the atmosphere, so it will occupy its only its volume. It will not occupy the whole atmosphere, exactly, because it is depending upon their particles. Now coming to the Gale-Lussac law. So, student, what is according to the Gale-Lussac law is that it gives the relationship between the temperature and pressure, but the constant volume. Okay, that what's the pressure and the temperature is there. So, law states that at constant pressure, constant volume, the pressure of the gas is directly proportional to the temperature. How? Gale-Lussac law. So, student, what they are saying according to this law, so these are the laws which are named upon the name of the scientist, like who has discovered it, so that laws has been named upon them. For example, Newton's law. You know, the Newton is a scientist, so they have given that as the Newton's law. Gale-Lussac law, matlab, it's like that Gale-Lussac has given that law, so we have named it as Gale-Lussac law. Okay, now according to it, what they are saying, that at constant volume, the pressure is directly proportional to temperature. How, student? That how pressure is directly proportional to temperature if the constant volume is there? How we can say that, students? That if it is proportional to each other? Because, student, what will happen when you increase the temperature? When the temperature increases, so the pressure is also going to be increased. How? See, student, when the temperature is increasing, so the particles will gain more kinetic energy, and when they gain more kinetic energy, so they will try to move here and there. That means they will try to collide with each other, and when they will try to collide with each other in more, like in more amount, so what will happen? There will be the generation of the pressure between all of these. Exactly, student. For example, if I'm moving, like if I'm moving on a road, on a any road, and if someone hits me, like if someone collides with me, so what I feel pressure na. Exactly, I feel pressure when someone hits me or someone collides with me. I feel pressure. So same thing happened with the gaseous particles, that when we increase the temperature, so the particles are moving like this. So when they are moving like this, so they will collide with a great pressure, and when they collide with great pressure, so that means we have increased the pressure as well. So it is like that, when the temperature has been increased, so the pressure will increase definitely. If the particles are moving, like temperature has been increased, so they have gained the kinetic energy, and they are moving, and at some point they will collide with each other with a high pressure. Exactly. For example, student, why always parents do not allow their students to move the bicycles or bikes or cars at a very high speed? Because they know if their balance is like, if they got disbalance or something happen like that, so they are moving with that high speed. If someone is going to be hit, so there will be more pressure, and you can say that there will be more harm, more damage will be there. So the same thing will be with the gases particles also, that when the temperature is high, so they will just try to move very faster speed, and due to which when they collide with each other, the pressure will also increases. Okay. And if the temperature is low, so and they are moving like this, like this, so they will collide like this, so there will be no such pressure. Exactly. So that's how, when temperature increases, so pressure also increases at that point of. So that is the Gale-Lussac law, student. So if I say that the first condition, P1 is directly proportional to T1. Second condition, that the P2 is directly proportional to T2. So I can write down it as P1 by T1 is equals to K, and P2 by T2 is equals to K. So again, I can write down it as P1 by T1 is equals to P2 by T2. You'll say that, ma'am, why you are putting them equal to each other? See, student, these are the equation for these particular laws, that you are getting some numericals over it, and you are going to apply these formulas directly. Okay. For example, they have given you that P1 is this, T1 is this, and P2 is this. Calculate T2. So you can directly apply the Gale-Lussac law. So all these are the laws which we are getting from, these are the equation we are getting from these laws, and we are going to apply them in the numericals. And you get the MCQs in your Olympiads and something like that from these numericals, from these laws only. So that's the point of view of these equations. Okay. So this is the Gale-Lussac law, students. So what we have studied till now, the Boyles law is there, which says that the temperature is constant. First, temperature is constant, then P is constant, then volume is constant, and we are getting all of these equations. P1 V1 is equals to P2 V2 from Boyles law. V1 by T1 is equals to V2 by T2. It is Charles law, and the Gale-Lussac law says that P1 by T1 is equals to P2 by T2. So that's the point. Okay, now it's the Avogadro's law. So now this is the last law of this session, I think so. Yes, which we are going to discuss. Otherwise, you'll say, "Ma'am, what you are teaching to us? We are getting so many laws. We haven't seen so many laws." Like you'll say that these are more than the laws which has been made by the government. Exactly. Okay, so now Avogadro. So there was a scientist named as Avogadro, and he has given you an Avogadro number also, which you are going to see in your chapter, that is in maybe in matters in this next chapter or after that. So it is the Avogadro's law, student. What he'll say, that there is a relation between the number of molecules of the gas and the volume. But what's the condition for it? Okay, I'll explain you this thing. Okay, so it's like fourth law, which is the Avogadro's law. So this law says that, students, that when the temperature and the pressure has been kept constant, so what will happen, that the number of molecules of gases, if I consider it as n, and if I consider the volume of gases as v, so this number of n is directly proportional to v. Okay. And how you can get this law? See, student, whenever you are having birthday parties or any parties at your home, so you have to blow the balloons. Exactly, you have to blow balloons so that you can decorate. And you know this thing, that how tough is to blow the balloons, and even though these muscles are going to be very painful after that, if you blow balloons exactly like 20, 30, 40, so it's a tough task. Now what I want to tell you is, initially when you are having balloons, so it is not like it is just a very tiny piece. Okay. So at that point, that balloon is not having any of the gaseous molecule inside it. Exactly, because how we blow the balloons, like by entering the gas into it from our mouth, or with any pumper, like the pumper, it is pumper or what, not like something like that, so that we can fill the gas inside it and the balloons will get blow. So what happens, student? See, initially when you start blowing gas inside that balloon, so what you'll see that slowly that balloon is going to increase its volume. Exactly, the more amount of gas you are putting inside it, more volume you are getting it. So what we can say that more number of the molecules of the gases is directly proportional to the volume, because when you are you have seen that thing from your eyes only, that when you blow the balloons, initially the size is this, and when you're continuously entering your gas from your mouth inside the inside that balloon, the volume of the gas balloon is going to be increased. That means we get this much of balloon also. Even though this much also, they are very bigger balloons as well. So how it has done that, the amount of the gas, that means the number of molecules of the gas entering into it, it is continuously increasing its volume. So you can say that the number of molecules is directly proportional to the volume. Exactly. And when we have that balloon of this shape, and if you slowly release the gas from that balloon, so what you will say that after some time the size of the balloon is going to be decreased. That means when the number of molecules are left very less inside the balloon, so the volume is also very less. So that's the point of the Avogadro's law, that the number of molecules is directly proportional to the volume. And one more thing, he says that it doesn't depend that what type of gas it is. The all of the gases will have the same number of the molecules when they are kept at the particular temperature and pressure. Okay, so if I say at first condition, if it is the n1 is directly proportional to v1, and at the second condition it is n2 is directly proportional to v2. So what I can see from here, student, that it could be v1 by n1 is equals to k, and v2 by n2 is equals to k. So from here again, student, if I write down its equation, it comes out to be v1 by n1 is equals to v2 by n2. So this is the Avogadro's law equation. Fine, student. And see what I'm doing here, it is, see students, like if it is the, I'm showing you that what I'm doing, it is the v1 n1 is equals to k, and it is v2 n2 is equals to k. Now you know that this k is equals to this k. Exactly. So what I can write down, and that's how we remove this k, that is the constant value. So we are getting such equations from here. So this is the Avogadro's law. I hope you get all of these points, my students. You are getting now? Good, very good. I want this thing only, that my students should get each and everything. Now, okay, express Kelvin 0 in degrees Celsius. There is a formula to because student, temperature is having two units. One is the degree Celsius and one is the Kelvin, and Kelvin is the SI unit of temperature. You know this thing, that the Kelvin is SI unit. So we can write down the temperature in Kelvin is equals to 273 plus temperature in degree Celsius. If you are having any temperature in degree Celsius, you can convert it into the Kelvin, and if you are having any temperature in Kelvin, you can convert it into the degree Celsius, but the factor we have to use is 273. So student, this is the formula to convert this. Now they have given that the temperature at degree Celsius is 0 according to that question, and we have to find out it into the Kelvin. So it's just that temperature of Kelvin is equals to 273 plus temperature in degree Celsius, that is 0. So it comes out to be 273 Kelvin. Okay, if the temperature in degree Celsius is 15 degrees Celsius, and you have to write down it in TK. So it's just that temperature in Kelvin is equals to 273 plus 15, and you will get your answer. That would come out as the 288. Exactly, 288 Kelvin. So that's how you can convert both degree Celsius to Kelvin, Kelvin to degree Celsius. I hope you got this point. So that's how you can do this type of question, the conversion of the temperature from degree Celsius to Kelvin, from Kelvin to degree Celsius. Okay, yes, you can see it's the Kelvin 0, that is the, okay, so what they have given, that the Kelvin 0 in degree Celsius. Okay, see, they have given the temperature Kelvin is 0 Kelvin. You have to convert in degrees Celsius. So it's just that TK is equals to 273 plus T degrees Celsius. So it would be what? 0 is equals to 273 plus T degrees Celsius. So the T degrees Celsius is equals to 0 minus 273. So it comes out to be minus 273 degrees Celsius. So this is the answer. Okay. Okay, now next question. Find the initial volume of a gas at 150 Kelvin if the final volume is 6L at 100 Kelvin. So you can see initial volume we have to find out. They have given this 150 K that temperature, and they have given the final volume and the final temperature. So what I can do here, students, we can see here that we have to find out the initial volume. So I'm writing it as Vi, which we have to find out. Then the Ti is given as the 150 Kelvin, and V final they have given it as the 6 liter, and T final they have given it as the 100 Kelvin. I have to find out. So what formula you are going to apply? It is the V1 by T1 is equals to V2 by T2. Exactly. And what's that formula is? That from which law we are getting it? V1 by T1. That is the Charles law, if I'm not wrong. Okay, I'll check this once for you that if I'm correct or not. Oh, just a second. So exactly, student, it's the Charles law which we are going to apply. Here it is. And first of all, student, you have to check that whether the units are same. If any of the temperature is in degrees Celsius and one is in Kelvin, so convert them into same. Okay, that's the very important thing for every question. So it's like we are going to apply the Charles law, that is the V1 by T1 is equals to V2 by T2. So I can write down it as Vi by Ti is equals to Vf by Tf. So it's just that Vi we have to find out. Ti is 6 is equals to Vf. Oh, sorry. It is not 6. It is 150. 150, and Vf if I see, so it is 6 and Tf is 100. So I can write down it as Vi is equals to 6 by 100 into 150. And if I solve it, so it is 3 here and it is 2 here, 2 and 3 again. So the initial volume comes out to be 9 liter. So you can see it is the 9 liter, and you can see when the volume increases, temperature decreases. That means, oh, sorry, when temperature, sorry, what I was saying, when the temperature is increasing, so the volume is also increasing, and when the temperature is decreasing, so volume is also decreasing. Exactly. So that's how you are going to solve these questions depending upon these laws. Okay, now last one. The law which states that the pressure remaining constant, the volume of a given mass of dry gas is directly proportional to its absolute temperature. So they are saying that that pressure is constant and the volume is directly proportional to temperature. So what's that law is? Exactly. It would be the Charles law that at the constant pressure, temperature is directly proportional to volume. So the answer for this question is Charles law. Exactly. So students, we have covered up all of these things in this session. That's what is the evaporation and how it process, and in the cooling, then what are the factors affecting in the evaporation, and we have discussed all of these laws, and we have seen that how it is working, all of these equations, we have solved all of these numericals. Okay, so just look at this video with the great attention. You will come to know good things like for your future also. Okay, and even though if you feel any query, any question comes in your mind, please post your question over the forum, on public forum, on or like private forum, or depending upon your condition. So you can post your questions, and exactly, students, you will get your answers, and that's how you will be pro in this chapter. Okay, so thank you for watching this session, and yes, keep learning from us, Canadians. Thank you.